Hi guys, so yeah, I'm going to take this class after quite a long time. Started doing something else and then thought that I'm not taking this class for some time over here. So basically today we are going to you know, make an understanding about friction. So friction is a very important concept in mechanics, and what friction necessarily you know stands for is, when two people do not get along, then we call that there is friction among them. And it's also true about bodies. When they do not get along in the same direction of motion, then the force which opposes their motion in the same direction is generally friction. A body on level ground plane can also experience friction, um, because of reasons which we are going to understand over here. Okay, so friction. Okay, so friction occurs because when we have a body, let's say this one, let's say it's on, a level plane. Macroscopically, you'll see that there is, these two bodies. This is a perfect cuboid, for example, and this is a perfect level plane, mirror finish, and everything. But in real life, it does not happen. What happens is, if you see the two-dimensional view of this, and if we delve a bit deeper, what really happens, what happens, that actually there are very teeny tiny asperities at the interface between the body and the plane, right? So when you start putting force, and let's say our coordinate system is x and y, or z f, then basically what happens is you're trying to start moving this body, but because of these asperities, they're locked. These asperities are locking the body to go in this forward direction, in the plus x direction, and that is the reason why friction is there in between this body and the level plane. So basically, what would happen is that if we draw the free body diagram, which we kind of learned in the last class, there will be a mass times gravity of the body, which will be which the body will experience in the downward direction. There will be a normal force which will be there at the interface of the body. This will be probably at the center of mass, and we'll go through that. And at the interface of the body and the ground, level ground, there will be a normal force. Now, because of the friction, um, the body. So if we write, since the body is not going to jump in the y direction, we can write n minus mg equals mass times 0 acceleration, n equals mg. So that satisfies the force equation in the plus y term, in the plus y direction. If you start writing in the plus x direction, we know that the body is not moving. So let's assume that there is some ghost force g, because of which the body is not moving. There is zero acceleration, and this ghost force has to be equal to F, right? If there is enough of that ghost force that that it is restricting the body from moving in the plus x direction, and this ghost force is called static friction. Static means the body is not moving, all right, and friction means it is opposing the direction of motion for that particular body in a minus x direction, right? So this is called static friction. Now let's suppose, so this is at time t equal to 0. Let's suppose we keep on increasing this force F, and at certain point in time, this body starts moving in the plus x direction. So let's say for that force F prime, my ghost force, there will be a new ghost force which will remain constant. So basically what we will assume is that once it is the body is able to overcome this asperities, there is going to be a constant G naught force in the minus x direction. So when there is a case of static friction, until and unless you keep on increasing the force, your G is increasing as a function of that given force at an angle of 45 degrees, because G and F are essentially equal. But as soon as um, the body starts to move, and then there is mass times acceleration in there, this G naught, this becomes a constant value, right? So for movement, F prime minus G naught is greater than 0, and that will cause some type of an acceleration, let's say A. And this G naught value is proportional to your normal force. Now you would assume, it's very difficult to understand this, because your normal force is acting in the plus y direction, but essentially your normal force is not only acting, is only acting in the plus y direction, that is its vectorial vectorial essence of that particular force, but the value of G naught will be proportional to the magnitude of this force only. And when you take out the proportionality constant, you get this value where mu k is the coefficient of kinetic friction. So once the body starts to move, you'll get something called G naught, and if the force keeps on increasing, the G naught will remain constant. Okay, so this is the point when the body started to move. Okay, this is the point when exactly the body started to move. F minus G naught is greater than 0, and you have enough driving force for the body to move forward. In the plus x direction, if there is something going on in the inclined plane, we will discuss that as well. So I hope this point is very, very clear to you. The ghost force, or the frictional force, which is opposing this force F, remains the same as the applied force until and unless the body starts to move. Once the body starts to move, we assume that the asperities are going to present the same amount of force over and over as the body is moving, and that constant force G naught is called kinetic friction, and that is given by multiplication of kinetic friction coefficient times the normal force, right? So exactly at the point when the body starts to move, the force will be also, so static friction to kinetic friction, at that time your force will be also equal to mu k n, just at the time when the body starts to move. Okay, so with that, I would say this is the general concept of friction, and now we will try to understand some of these implications in an inclined plane. I'm going to keep this lecture short because I realized, and somebody told me that the lessons are getting bigger and sometimes very hard to grasp them. So basically, I'm going to keep this very, very short. So I'm going to go to this concept of inclined plane. We'll try and understand the concept, and we'll restrict our participation in understanding the concept of friction till that point today. And after the fact, we'll add some more concepts which we'll talk in further lectures, and I will be much more regular in these lectures now. So that's what I thought. A lot of people kept on emailing me that they're missing the lectures and things like that. So I thought, why not do it? All right. So this is the concept here. I guess while I was blabbering, you got enough time to put this as notes. If not, just pause the video, do whatever you want. You know, have them covered as notes, and now we are going to understand the essence of friction, or what is friction in terms of an inclined plane. Okay, so for an inclined plane, all right, for an inclined plane, okay, not helping out today. So for an inclined plane, which is at an angle theta with respect to the ground at time t equal to t. So let's say it was at theta equal to 0 to start with, and is at time t equal to 0, at time t equal to t, it is at angle theta equal to theta. So the concept, what I'm trying to understand and hopefully make you guys convinced about this concept, is that at a general angle theta, at this rough interface in between the body, small mass m, and the incline, there will be a normal force um, perpendicular to the interface mass inclined interface, and positioning towards the mass, and then there from the center of mass there will be a force mg, and if you take the components of it, and so this is general xy, and this is general x prime y prime. So if you take the components of it in the minus x prime direction and minus y prime direction, so we'll get mg cos theta, and we can forget about this force mg sin theta. So once you have taken the components of the force, you can forget about the real force, the original force, and then only play with the components. And let's say at a general theta equal to theta, there is this ghost force again, and if the body is not moving, then your ghost force, which is in plus g direction, plus mg sine theta, so this is I cap, mg sine theta minus I cap is equal to 0, so g plus mg sine theta, which is negative sign, is equal to 0, so g equals mg sine theta. So theta is g divided by mg sine inverse of it. Okay. Now if you keep on increasing this angle, then at a certain angle theta naught, let's say the body starts to move, then this ghost force g will become g naught, as we discussed earlier, and then what you'll get is that this g naught at t equal to t naught at theta equal to theta naught, when body starts to move, meaning you have g I cap plus m g sine theta naught minus I cap equal to 0. We will also call it g naught because this is theta naught. then your G naught, and that has to be greater than 0 because it already started moving. So your G naught, and in the minus x direction, so it has to be less than 0. G naught minus mg sine theta naught is less than 0. So theta naught has to be G naught to be mg sine theta naught, sine theta naught G naught over mg, theta naught is sine inverse G naught over mg. So theta naught has to be less than sine inverse of G naught over mg. Okay. What does all this mean? This means that theta naught has to be less than this particular value in order for it to start moving. Now we know that when it starts to move, G naught becomes proportional to your normal force. Alright, in this case, if we solve in the y direction the force equation, then we have n j cap, and at theta equal to theta naught, this component will become mg cos theta naught plus mg cos theta naught minus j cap. That has to be equal to 0 because it's not, the mass is not moving or jumping in the plus y direction, y prime direction, and your n becomes equal to mg cos theta naught, and g naught, which is proportionality coefficient of coefficient, this is called coefficient of kinetic friction, give times mg cos theta naught, right? So we have to put it back here. So your G naught now from this and this, G naught is mu k times mg cos theta naught is to be less than mg sin theta naught. So tan theta naught, which is gets when we divide this, and mg will cancel on both the sides, has to be greater than mu k. So your theta naught has to be greater than tan inverse of mu k, which means that if you know the kinetic friction coefficient, you take the tan inverse of it, you know exactly when, you know the exact angle when the body will start to move. So knowing this kinetic friction coefficient, which is a material parameter, is very, very important, so that you know exactly when the body will start to move, at what angle the body will start to move. So with that, I'm going to conclude this lecture for today. I hope you had some good understanding of friction, and I welcome all your questions, whatever you have, so that we can make this course eventually even better. And just shoot me all your questions. I'll try to answer them to the best of my understanding. And with that, I bid you adieu. Thank you. Have a great day and great night wherever you are.